Hello guys, welcome to this new video. In this video we are going to solve a cinematic problem. It is again Iran's Physics Olympiad at level 3. It is a very good question. Uh, let's actually read the problem without wasting the time. As you can see in the picture below, actually we have steps with general angle alpha with respect to the horizontal. What does it mean? It means that in this picture, actually don't be confused about the picture. It is we have several steps, and just if you actually draw a straight line from the edge of this step, the angle that this straight line makes with the horizontal is just alpha, which I showed it in here with red color. Okay, the gravity acceleration is g and it's downward. I forgot to actually draw g. It is g, it's the gravity, and it is downward. And also the height of each step is h. It means that this is h, this length actually is h, this length b to a1 is h, and all of them, for example b1 to a2 or b2 to for example it is a3, they're all h. We shot a ball from point M. Where is M? This is M. I actually draw the ball with blue color. It is the ball which it is actually shot with the initial velocity actually v0. We shot a ball from at point M on step AB. It is step AB. This is A and also this is B. It is step AB. Which we call it zero step. The step number 0, it is the step number 1, a1 b1. This is the step number 2, and we have n steps. It is actually I didn't draw all of them. With initial velocity v0 and with angle theta with respect to the horizontal, suppose that the distance from M to B is capital L. This is actually L. I draw it here, and with color I draw it with color actually orange here. MP is L. The ball collides to next step. I mean the ball actually, if when we shot it after that, it collides to the step 1 at point M1. We suppose that after each collision the horizontal component of velocity doesn't change, but the ratio of the magnitude of vertical component of velocity after collision over the magnitude of the vertical component of velocity before collision is equal to E, which we call it actually jumping coefficient, and it's less than 1. What does it mean? It means, for example, consider that this is the step 1. This is step 1. Step 1. And for example, consider that before collision, it is before collision. Let me to write it with, for example, before collision here. Before collision, color black. And also, for example, after collision with red color. It is, for example, consider here. Actually, there isn't any distance between these two actually balls. They are in one place, but I actually draw it like this to actually for you to understand it better. Consider that this ball is before collision. It has a velocity vx with respect to the horizontal, in the horizontal direction, the x direction. This is x and this is y. And also it has a vy downward, because it is actually coming to this step. It is coming to this step, and after the collision it is going up, and with v prime of x and also v prime of y, which it is upward. What is the relation? And what the question says is some relation between these between these velocities. Actually, the question says that vx is equal to v prime of x, and also v prime of y. Sorry about this, v prime of y divided by Vy is equal to E. This is what the question says about the velocities before and after collision in the direction of y and x. We just say it that E, which it is less than 1, actually it means that our magnitude of velocity actually decreases after collision. So which we call it actually jumping coefficient, and it's less than 1. The ball collides to next step at point M2 and passes each step one by one. It means that it collides the step 2 at point M2, it collides at step 3 at M3, and so on to, for example, the nth step. Okay, what the question wants from us is that we should actually find v0 and theta, so that we should find v0, the initial velocity, and the initial angle that we shot the ball, so that am is equal to a1 m1, and it is equal to a2 m2, and it is equal so on. For example, it is equal to an mn. What does it mean? a1 m1, it is this actually. Let me to color draw it with color actually brown. Let me to draw another picture. Let me draw to another picture to actually write something on it. Let me to copy this and paste it here. This is our picture. This is the picture of our problem, and let me to erase this, actually the extra shapes in the, no, it was okay, this line, and for example this alpha, or for example just that. Okay, the am actually here should be equal to this actually length, and it should be again equal, it should be equal to this length, and so on. Means the movement of the ball repeats after each collision on each step. Find a condition for L such that after the shot ball doesn't come back to the zero step. It means that if we shot the ball, we don't want the ball to hit again to the actually this step 0, which it is actually AB. We don't want our actually picture to be something like this. Let me to show you with color brown. We don't want it to be something like this. It is A and this B. We don't want this to happen. We want that our ball actually passes the first step. Okay, let's actually solve the part A with color black. Okay, what should we do actually with this part of problem? What does it mean that am should be equal to a1 m1, and it should be equal to a2 m2? If you paid attention that our actually step is something like this, each step is something like this, that it is h and the angle is alpha here, so our so this length of each step is just h times cotangent of alpha, cotangent of alpha. So each step actually has equal base. I call it base, for example. Each step has equal bases. So if a1 m1 is equal to am, and so if you what is actually the magnitude of, what is the length that the ball actually passes in the x direction? I mean, what is this length? What is this? Our question is that what is this length from here to here? Sorry about the line. What is this length? What is, let me to call it, for example, r. What is r? What is the relation between r and this is, for example, consider this is it, that it is R2, it is R1, it is R1, for example, it is R2. Let me to call it R0, means before, it means after shot, before the first collision. It is R1 after the first collision, and R2, and so on. R0 is actually equals AM plus MB. Okay, and sorry, it is actually, sorry, I wrote it wrongly, MB plus A1 M1, and R1 is just equal to M1 B1 plus A2 M2, and we know the fact that A1 M1 actually plus M1, for example, B1 is equal to H cotangent of alpha, and also AM plus MB is also H cotangent of alpha. So, and we know that and we know from the assumption of the part A that AM should be equal to A1 M1. So from actually this equation, let me write it here, AM should be equal to A1 M1. So from this these equations, we notice that AMB should be equal to M1 B1. What does it mean? It means that this part MB, which it is equal to L, should be equal to M1 B1. So this should be also BL, and also M2 B2 should be L, and also MN BN should be L. So actually we understood that M1 is equal to, let me to write it vertically, M1 MB is equal to M1 B1, and also A1 M1 is equal to A2 M2. So from these equations we can also understand that R0 should be equal to R1, and also etc. It should be equal to Rn. It means that the value that the ball actually goes actually horizontally should be equal in the duration of time. So if we want to actually write the equation of ball, the movement equation of ball in the x direction, what should we write? Actually, we know that there is no acceleration in the x-axis, so the movement of ball in the x-axis is just actually just constant velocity movement. Let me to see that if I am recording. Yes. The movement of our ball in the x direction is just a constant velocity movement. So x dot means the velocity in the x direction for the ball is v0 cosine of theta, because we shot it with this velocity at the x direction. So because the v0 and cosine of theta are actually they are constants, so if we integrate from this equation, we obtain that x of t is just v0 t of times cosine of theta. So after each collision, we know that our v in the direction, our velocity in the direction of x shouldn't change, and also we understood that our velocity in the direction of x is always equals to v0 cosine of theta. So our velocity after the first collision in the x direction is also v0 cosine of theta. So let me to write here, it is also v0 cosine of theta, v0 cosine of theta. Here again it is v0 cosine of theta. Also just our velocity component in the vertical changes after each collision, and also during the movement on in the air, it just our vertical component of velocity just changes. Our x velocity component is actually constant during the whole of the problem. So if we want to actually r0 be equal to r1, because our velocity in the x direction is constant, so the time of our movement for actually each part should be equal to each other. It means that if I call the time actually where our ball is here in the air, here is t1 and here is t2, so we can say that uh, r0 is just v0 t. Let me to call it t0, not t1. Let me to call it t0. It is just t1, and also we have tn. I don't want to write it. V0 times t0 cosine of theta. R1 is v0 t1 cosine of that theta. Then Rn should be just v0 tn cosine of theta, because we want to r0 be equal to r1 and it should be equal to r2 and so on to rn. So actually our v0 t0 cosine of theta should be equal to v0 t1 cosine of theta, and also it should be equal to v0 tn cosine of theta. We can actually divide all of these equations by v0 cosine of theta, and we understand that t0 should be equal to t1 and it should be equal to tn. Okay, but what is actual t0? What is t0? What is t1? What is tn? What are these actually? What are these times in terms of our velocity and the angle we have and the edge and all of the geometric actual parameters that we have in the problem? Okay, let me to calculate t0. Let me write the actually the movement of our ball in the y direction. In the y hat, we just have a y, means the acceleration in the direction of y equals to minus g. So if I integrate from this actual equation, it is g is constant, minus g is constant. So y time of function of t as a function of t is just minus g times t plus v0 sine of theta. If we integrate, we know that here actually appears a constant, and we should actually find this constant with initial values. And if we put here actually t equals 0, our we know that our velocity at the time 0 is v0 sine of theta, which c would be equal to v0 sine of theta, so v0 sine theta. And if I again actually integrate from this equation, I can obtain that y as a function of t will be going to be minus gt squared over 2 plus v0 times t sine theta plus y0, which if I put actually origin at the 0 step, so y0 is going to be 0, so I can eliminate this term. So what is the time which the time t0 is the time which our ball is at place. If I put origin here, so our ball is at place minus h. Our y of our ball is minus h at time t0. So I can write something like this: minus h. I need to write it below. Minus h is going to be minus g t0 to power 2 over 2 plus v0 t0 sine of theta. And I can solve this equation for actually t0. So it is g t0 squared over 2 minus v0 t0 sine of theta plus minus h is equal to 0. And it has two answers. I call it t0 number 1 and t0 number 2, which it is the roots of this equation, and it is just 1 over g times actually v0 minus v0 sine of theta plus radical v0 square sine theta square plus 2gh and also the second root of this equation is just 1 over g v0 sine theta minus radical v0 square sine square of theta plus 2gh. But which one is correct? Which time should I actually accept it, and which one is not correct? You should know that our time, our t0 should be actually positive. It shouldn't be negative. Our t0, our t1, our tn also is positive. They are not actually negative values. Okay, so here if you pay attention to t0 number 2, you can understand that it is v0 sine of theta minus radical v0 square, which it is something plus 2gh, which it is something greater than v0 sine of theta. So it is actually b minus b negative, and t02 is negative. So we shouldn't actually accept this one, and we should accept just this one. So t0 is just something like 1 over g v0. I don't write it again. This is actually t0. This is actually t0. Okay, we understood that our t0 should be actually be constant. Our t0 should be equals to t1, and it should be equals to t2, and so on. Okay, you can see in this equation, in this equation, that the only parameter that our time is affected by is v0 and sine of theta. The parameters that are related to the ball, to the first actually initial condition of the ball, they are just v0 and sine. It means that the only parameter that affects the time of our movement in the air is just vy. It means that we should actually know that it means that for example, for the first part, if here we have vy of, if sorry, here if for example, for the first, if we shot, for example, consider that we have vy0 at the second, after the first collision we have vy of 1, after the second we have vy of 2. If these vy's are equal, then actually you can see here that our times are going to be equal. So vyn should be equal to vyn plus 1. If we find this condition, if we actually write this condition in terms of mathematics, we can understand that what should be v0, what should v0 be. But how can we understand vyn in terms of vyn plus 1 in terms of vyn? Consider that this is our actually ball, and it is actually being shot like this. It is being shot like this, and this is after the collision we have vyn plus 1, and it is also here vyn. We know that our vy with the function of time is just, we wrote it here, it is our vy with the function of t is just minus gt plus vy0. Here I wrote v0 sine of theta because I was writing the equations for the shot, after after shotting the ball. But if we are actually at the nth collision, it is going to be vy of n. And also we understood that the time which the capital time tn is going to be something like 1 over g vyn plus, here I wrote plus v0 square sine square theta, which it is actually vy. Vy after the shot, but after the nth shot it will become actually Vyn square plus radical Vyn square plus 2gh. And if I and we know that Vy of t is going to be actually, consider that before the collision our Vy was actually V prime Yn. After the collision it is before the collision, because the velocity, we know that we should actually do this equation for them. We should do this equation for the velocity. We have this relation for the velocities before collision and after collision. So before the collision, it is before the n+1th collision, and it is just after the n+1th collision. So Vyt is going to be V prime of Yn+1, which it is going to be, if I substitute this t into this equation, it is going to be actually something like minus radical Vy, sorry about Vy n square plus 2gh. And also we know that sorry, it is our Vy, it is something like this, it is minus Vy. So we know that we know from this equation, from this actual equation, we know that V prime y means Vyn plus 1 divided by minus V actually V prime Yn plus 1 is just going to be E. So Vy of n plus 1 is going to be just E radical Vy n to power 2 plus 2gh. So here we found actually the equation for Vy's, and we said that Vyn should be equal to Vyn plus 1. From here, actually let me to say it's star equation. From the star equation we understood that Vyn should be always constant. So here we can say that we can obtain Vyn. Let me to substitute Vyn plus 1 by Vyn. If I actually square both sides, it is e to power 2 Vyn to power 2 plus e to power 2, sorry, 2 e to power 2 gh. From here we can understand that Vy of n is going to be something like e radical 2gh over 1 minus e square. And so Vyn is always constant, and it is equal to this. So our Vyn, we know that before the first collision means after shotting, our Vy is just V0 sine of theta. It means that it should be actually it should be okay, this equation should be okay for all n's, n0 and 1 and 2, and we know that Vy0 should be, so because of this equation, should be this, and we know that Vy0 is V0 sine of theta, and it is equal to this. So this is actually one of the actually equations for solving V0 and theta. We should actually find another equation for V0 and theta to actually do the two unknowns and two equations to solve each of them. So let me to call this the equation number I. Equation number I is so important. Let me to color it with actually blue, with a blue cloud. But how can we obtain the other equation? Where should we actually obtain the other equation? Actually, we should obtain the other equation by actually the fact that our look at here, our movement in the x direction here was just actually equal to h cotangent of all alpha. It means that r0, they are all equal to h cotangent of alpha. We should actually use this equation. And what is our movement in the x direction, for example, after the nth collision? Here we have the nth collision, and we know that we have v0 cosine of theta in this side, because it is going to, I said that it is constant in the whole problem, our velocity in the x direction. And just we know the time, we know tn, here we know tn, so v0 cosine theta times tn is going to be this length, which it is equal to, actually here we understood it is equal to h cotangent of all alpha. So let me to write the equation. v0 cosine of theta, equation for movement in x direction. So v0 cosine of theta times actually tn, which it is 1 over g. Let me do this, g over g, vyn plus radical vyn square plus 2gh. And also we understood that we understood that vyn square plus 2gh is equal to vyn plus 1, which it is equal to vy of n over e. So I can write it like something like, let me call it h cotangent of alpha, and so it's going to be v0 cosine of theta over g vy of n plus vy of n over something like e. Actually, these are the same. These two equations are same. And if I factor the vy from vyn, and which we understood that vyn should be equal to v0 sine theta, so if I factor vyn, which it is v0 sine theta, it becomes v something like this. And if I actually substitute, it is h tangent of alpha. If I substitute v0 sine of theta, I mean, if I substitute I equation in this equation, I can understand that v0 to power 2 v0 cosine of theta over g multiplies by 1 plus 1 over e times v0 sine of theta, which it is actually e radical 2gh over here 1 over 1 minus e power 1 minus e square, is going to be h cotangent of alpha. So from this I can actually, if I can write it something like this, 1 plus e, and so our v0 cosine of theta is going to be something like gh cotangent of alpha over 1 plus e times radical 1 minus e squared divided by 2gh. It is v0, actually it is actually the double I equation, from the equations I and double I, we will understand that V0 sine of theta is going to be something like this, and V0 cosine of theta is just something like this. And now we have two equations for V0, and we have two equations for theta and V0. If I actually divide the ith equation by the double ith equation, I can obtain that tangent of theta is going to be something like this: e radical 2gh divided by this parameter multiplied by the inverse of v0 cosine of theta, which it is something like this, which I can actually say that tangent of theta is just e 1 plus e divided by gh cotangent of alpha, and 2gh divided by 1 minus e 1 plus e, and I can eliminate these two terms and also gh from the both sides, and it is going to be e is going to be 2e divided by 1 minus e tangent of alpha. So I found the tangent of theta, which the question wants us. It says that we should actually find theta, and we found it. And also now that we found theta, we can substitute this theta in both, for example, each of these equations, I or double I, and find V0. I wrote it before. I think that V0 is going to be something like this, if I don't make mistake. If you found out that I made mistake in these writings, please comment below and let me to be aware of these mistakes. But I think V0 is going to be some bad expression like gh cotangent of alpha divided by 1 minus e square 1 minus e over 2gh, again this 1 minus e square plus 4e square tangent square alpha. This is square. This is actually, sorry, 2 power 1 over 2. And I think that V0 from these equations, we can find V0 something like this. Okay, so actually this is part A of the question. Let's go to actually part B, which it is actually the challenge, which it has some challenges to actually do this part. First, I should tell you some notes about, for example, about these, the fact that, for example, epsilon here is going to be so small. It has some tricks to calculate this, to actually solve this part of the problem. It says that suppose that we don't change the initial angle theta, but we increase the initial velocity to v0 plus delta v0, such that delta v0 over v0 is equal to epsilon, which it is very small. Suppose that the ball collides to all first n-1 steps, but passes the nth step. Find n for e, and it says that for some parameters you should calculate the n, and it has a note that we should actually neglect epsilon to power 2 and power 3 and power 4. It means that all the powers that are greater than 1, we should neglect them in the actual calculations, in our calculations. So from here, let's to solve part B. Let's solve part B. But before that, I want to actually solve this part. I want to actually say some notes. I want to tell you some notes. And that note is nothing, just that if you want, for example, consider that you have an something like this. For example, a and b are numbers in the real actually field. A and b, for example, to power 2. You know that it is going to be a2 plus b2 plus 2ab. But if I say that b over a is so small, or for example, consider that I tell you to calculate a plus b to power n, which it is going to be a n plus, for example, n a to power n minus 1 b and some other actually terms. But if and which it is so hard, but if I tell you that b over a is so small, means, for example, consider that b is something like, for example, this, sorry about this notation, b is something like, for example, this, and a, for example, is 100. It's so small. You can actually do something else with it. You can say that, oh, sorry. You can say that I will actually do something like the above, and I will write a plus b to power n, something like a n plus n a to power n minus 1 b plus some extra actually terms. But because b here, this b is so small, I can neglect actually the other terms. For example, b2, b3, b4. I can suppose that all of them are 0, and just I can say that it is a plus b to power n. It is just equal to a power n plus n a to power n minus 1 b. It means that I can do something like this, for example, with this actually expression. Okay, just this. I want to actually tell you this note, and so let me to call it a note, not notes. It's just a note. So with this actually fact, let's to solve the part B. And what happened if we actually increase this velocity? If we increase it to, for example, v0 plus delta v0. Actually, what happens is that this parameter, which we called it r, which it is our movement of ball in the x direction after, for example, each collision, actually it is not going to be actually equal to h cotangent of alpha more. Actually, it is going to change because we changed our velocity. But how can we understand how much does each r change? For example, how much r0 change, or how much does r1 change, or how much does rn change? Are they changes equal to each other? Means, for example, if I call, for example, consider that if I actually change velocity to v0 plus delta v0, our r0 is going to be changed to r0 plus delta r0. Our r1 is going to change to r1 plus delta r1. Our r2 is going to change to r2 plus delta r2, and so on. But how can we obtain what is delta r0, delta r1? Are they equal? I mean that because we understood that r0 is equal to r1 and it is equal to rn. It is r actually r delta r0 delta r's actually, are they equal to each other too? How can we obtain that? Actually, the note of solving this part is that I told that you should understand, you should be aware of the fact that our velocity in the x direction doesn't change in the whole problem, in the whole duration of the problem, during the problem, our v of in the direction of x, our velocity component in the direction of x doesn't change, because we don't have any, for example, any acceleration in that term. But our v in the direction of y changes when the ball is in air, when the ball hits the each steps, and something like that. But you should be aware that our velocity in the x direction is not going to change during the problem. So if you change, so let me to write the note here, our actually our velocity, our v of x is not going to change, is not going to change. So the x of t, and we understood that the x of t is just vxt, because x dot is constant. So if we integrate from this equation, and if we put the origin on the place where the ball where we shot the ball, so we can say that x of t with a function of t, as a function of t, is going to be vx times t. So if we want to calculate actually these r's, r0, r1, and r2, and if we want to find its changes, for example delta r0, delta r1, if we want to find them, we should understand actually how does our how do our times change when we actually do this change to v0. It means that if we change our velocity to, for example, v0 plus v1, let me to copy this picture again to actually do something on it. Paste it. Let me to paste it here. Actually, when we change this v0 to something like this, v0 plus delta v0, our time in when actually the ball is in the air before the first collision is going to be t0, which it is going to be I called it t0, which it is going to be something like let me to I wrote something wrong here. This r0, you may say me that you may say me that this r0, I can eliminate these r0s from both sides, so delta r0 is 0. Let me to call it r0 like this, and this is our delta r0, and this is r. Let me to call it r0. This is r0. They are actually notations. You can do what you love with these expressions. It's important for you to understand what we are talking about. Actually, r0 is this. I changed it to r0 and r1, and actually I love to change these two. I want to tell that it is going to be t0, the time which the ball is in the air before the first collision, and it is going to be t1, and also we have tn, and t0 is just t0 plus a delta t0, because our velocity changes here, our velocity in the y direction changes, and we understood that our time, the time which we our capital T, which it is the time which the ball is in the air, is just a function of vy of n. Which these parameters actually are related to the ball. For example, t is also a function of h, or it is also a function of g. But g and h are not ball's parameters. Just vyn is the ball's parameter. Because we didn't change h and g, we should just actually focus on the functionality of t as a function of actually ball's parameters, which it is vy of n. So if we change actually vy of n, our t is going to change, and if we actually change a very small if we have a very small change in v in the direction of y, so we are going to have a very small change in the times which the ball is in the air before each collision. So t1 is going to be also t1 plus delta t1, and also tn is going to be tn plus delta tn. And we also know the fact that t0 is equal to t1 and it is equal to tn. We know this fact, but there is another question that are these delta t's equal? Or for example, if r is t delta t0 is equal to delta t1, or is it equal to delta tn? We should actually obtain it. We should actually calculate it. We can't say, for example, that yes, they are equal, or no, they are not equal. We should actually find each, for example, if we should find actually delta t for example, this delta v0, and then actually calculate delta t1, for example. And there is another actually challenge with this part, that when we shot the ball and it hits the ground, it hits the next step, we understood that the magnitude of our v in the direction of y doesn't change, because we said here that vyn plus 1 is going to be equal to vy here, vyn. We said that if we want our in fact our range of ball, range of ball is the movement in the x direction. If we want it to be same for each actual collision, our v in the direction of y shouldn't be changed after each collision. But if we actually add some delta v0 to v0, it is going to be changed. Our vy is going to be changed. I can say that vy1, like actually t's, like t's and r's, I can say that vy1, for example, is going to be vy1 plus vy1 plus delta vy1. Also vy0 is going to be vy0 plus delta v0, delta vy0, sorry, delta vy0, vy2, and also so on to vyn. Is equal to vy actually n plus delta vyn. Actually, if we want to study actually how our r's are going to change, because we know the velocity in x direction, we should study that how our t's are going to change. And because the t's are functions of our vy's, for actually studying that how these are going to change, t's are going to change, we should understand that how our vy's are going to change. It means that I should actually find vy1. It means that I should find that how our delta vy1 is going to change by actually changing in the initial velocity. And I forgot the fact that we know that vy0 is equal to v0 sine of theta, and they are all actually the same. And vy1 is equal to this, it is equal to vy2, and it is same to vyn. But how can we obtain that? How does it change? We can use actually this equation. This equation, we found this equation here. We said that so let me paste it here. We said here that vy of n plus 1, it doesn't matter that what is vy. It actually it doesn't matter that what is vy. Our vy n plus 1 is going to be something like ve times radical vy n square plus 2gh. it doesn't matter that what is vyn. We obtained this formula actually from the motion equations. If you paid attention, we obtained, where is it? We obtained this equation by actually considering that we have a vyn at the nth collision. It doesn't matter where is the ball or what happened to the ball, and just the time that the ball is in the air is tn, and we found tn here but with the function of actually vyn, and we replaced it in this equation, and we found the velocity before a collision to the n+1 step, and we used actually the jumping coefficient to actually find the velocity after the n+1 collision as a function of the ball's velocity in y direction after nth collision. So this is a general formula, and we can use it to obtain vyn+1 from vyn, no matter what vyn is. So if I for example, I want to calculate, for example, consider that I'm going to calculate vy1. So vy1 is going to be just e radical vy actually 0 square plus 2gh, and we know that vy square is vy 0 plus delta vy 0, and I forgot that to say that delta vy 0 is just delta v 0 sine of theta, because our ball is going to shot with the velocity v0 plus delta v0 with angle theta. So our vy0 is just something like v0 plus delta v0 sine theta. So it is going to be v0 sine theta plus delta v0 sine theta. So if I actually substitute this vy0 in this equation, I can obtain this, that it is something like v0 sine of theta plus delta v0. Let me to do something like this: v0 plus delta v0 square plus 2gh. And now we use the note that I talked about here, that if b over a is so small, we can actually neglect other terms, and just say that a plus b times a plus b to power n is just something like this. Here delta v0 over v0 is very small, so we can do the same. So vy1 is just going to be something like this: sine square of theta v0 square plus 2v0 delta v0, and we neglect actually this term. We don't use this term. We consider that we suppose that it is 0 plus 2gh, and it is equal to something like this: v0 square sine square theta plus 2gh plus 2v0 delta v0 sine square of theta. And again, I can write radical as something like this. Again, you can consider that this is a, and consider this is b, and we have a plus b to power 1 over 2, where b over a is so small. Why b is so small? Because we have delta v0 in here, and we know that delta v0 is so small. So I can say that it is, what is it? Sorry. Okay, what is a plus b to power 1 over 2? It's just a to power 1 over 2 plus actually 1 over 2 a to power 1 over 2 b. It is something like this. So if I use this note, I can say that vy1 is going to be just e actually radical v0 square sine square theta plus 2gh plus 2 times radical and v0 square sine squared plus 2gh, and here b, which it is 2v0 delta v0 sine square of theta, just this. Yes. And also we obtained something that v0 sine theta is something like this. We obtained this equation from part actually A. We know that v0 sine theta is something like this, and also when if we substitute actually this v0 sine of theta in this equation, we understand that it is just v0 sine theta over e. We just understand that it is it. So, and this is also this. So if I substitute these radicals with this simple actually term, we obtain that it is v0 sine theta over e, plus I can eliminate these 2's from the denominator and numerator, v0 delta v0 sine square of theta over v0 sine of theta over e, which I can send this e into the denominator and call it e here, and I can eliminate this sine of theta with this, and this v0 with this v0, and I can multiply this e in these two terms, and we can say that it is v0 sine of theta plus e square delta v0 sine of theta. So we as we expected that vy is something like vy1, which vy1 is just v0 sine of theta plus a delta term plus a small term, and we found this small term. So we understood that delta vy1 delta vy1 is just actually e2 delta v0 sine of theta. It means that we found that how much our velocity after our vertical component of velocity is going to change after the first collision, when we actually changed our first velocity and we increased it to v0 plus delta v0. Actually again from because now we have vy1, this is something like this, so we can again use this equation to find vy2. And if we do this, I don't want to write anymore. If we do this work, we can understand that it is going to be something like this, e4 delta v0 sine of theta, so on. If we do the same for the nth, after the nth collision, we found actually the changes in the nth collision, which it is going to be e to power 2n, actually delta v0 sine of theta. So now that we understood that what is our actually vertical component of velocity after each collision, so we can now understand that what are our t's, what is our t0, what is our t1. Let me to find actually t0 and then actually find t1 and tn to actually find out that what is the time that our ball is in the air for each collision. For example, let me to find actually t0. We found t0, we found actually tn. Here we found tn. Let me to find the expression. Here is the tn. Let me to copy this actually and paste it there. Need to paste it in the middle of the page, and yes, so this is Tn. So for example, we can find actually T0 as 1 over G, Vy actually 0 plus radical Vy 0 to power 2 plus 2gh. So we had Vy0, which it was just Vy0 was just V0 sine of theta plus delta V0 sine of theta. If I substitute this second equation, the first equation, I can obtain that T0 is just 1 over G V0 plus delta V0 sine of theta plus, and this is the same radical. This radical is, let me write it. This sine 2 theta V0 plus 2, actually it is something like this, 2 V0 delta V0 plus 2gh. Again, it is just this. It is just actually this Vyn square plus 2gh, which we substituted actually Vy as Vy0, which it was actually V0 plus delta V0 sine theta, and we actually do something like this, some approximation, something like that to this, and we obtained that it is going to be something like a to power 1 over 2 here, a to power 1 over 2 plus 1 over 2 a to power 1 over 2 plus b. So it is going to be the same. It's going to be 1 over g V0 plus delta V0 sine of theta plus actually radical V0 square sine square of theta plus 2gh plus what was the expression? It was just something like this. Let me do, if I can copy this, yes, let me to paste it here as in here, which we understood that which we said that if we substitute V0 sine of theta, which we obtained it here, we can understand that we are going to have just V0 sine theta over E. This term, they are equal to each other, and we will say that T0 is going to be 1 over G V0 plus delta V0 sine of theta plus V0 sine of theta over E plus actually E delta V0 sine of theta. Let me check if it is true or not. V0 sine of theta, E delta V0. Okay, it is true. And now I can say that T0 is 1 over G V0 sine theta plus V0 sine theta over E plus 1 over G plus 1 over G delta V0 sine of theta plus E delta V0 sine of theta, which I can actually factor the terms V0 sine of theta. So T0 is going to be V0 sine of theta over G1 plus 1 over E plus actually delta V0 sine of theta over G1 plus E. And this is actually we said that each t, for example, T0 is going to be T0 plus delta T0 T1 is, and which the T1 T0 T1 and Tn are the same. So here it is actually T0. It is actually T0, and also this is delta T0, which it is small because it is some expressions which it is multiplied by actually delta V0, which it is so small. So if I do the same equation for example, consider that if I want to find t1, consider that I want to, oh, what is, consider that I want actual t1. If I do the same equations from, actually we use this equation t1, actually we need actually vy1, which we actually obtained it here. We obtained vy here, vy1, vy2, vy3, vyn, sorry, and we obtain them. I will understand that tn is going to be something like, actually it's going to be something like this term, which it is constant, plus e2 delta v0 sine of, so for example for the tn, I will actually here generalize it for n. It is 2n e power 2n delta v0 sine of theta over g 1 plus e. So we found actually tn, and we found its changes. We found its changes if we have a little delta v0. So now that we have each piece, we can have each r's, for example r0, r1. But how can we have it? Just actually, for example, if we want rn, we should actually multiply, we should actually say that it is v0 plus delta v0 cosine of theta, our velocity in the x direction, which it is constant, times tn. If I actually calculate it, it's going to be v0 plus delta v0 cosine of theta times, let me to say that tn is something like t, for example, tn plus delta tn. Delta tn is something like the, which it is tn, and happen to this, sorry about this, which it is tn, and it is just t and delta tn. If I calculate this, I will obtain that cosine of theta v0 tn plus v0 delta tn plus delta v0 tn plus delta v0 delta tn, which I can again neglect this term. Why? Because delta tn is something like delta v0 times a constant c. And if I substitute this in this here, like we can see that it is we have two delta v0s, which they are actually, we are multiplying them by each other. So what so we can actually neglect this term, and we can say that it is 0. We can make approximation and call it 0. And so here we understood that r, actually let me to call it rn, rn, like this, which it is actually equals to rn plus delta rn. So we understood that rn is going to be v0 cosine of theta tn, and delta rn is going to be just a cosine of theta times v0 delta tn plus delta v0 tn. We found out something. We found out just that delta rn is something like this. Now we know that actually we know that how much our each r's is are going to change if we actually have a little change in delta v0 in v0 in the first in the initial velocity. The answer, the question wants us that the ball collides the n-1 steps, but it passes the nth step. What does it mean? It means that, for example, here you have a delta r for this. For example, r0, it's going to be here we have a delta r0, here we have a delta r1, and also for the n-1th collision we have delta
n minus 1. What does it mean? R1, it means that we had the first collision and we are going to have the second collision. So Rn, it means that we had actually the nth collision and the n minus 1th collision, and we are going to have the nth collision. But we don't have the nth collision because actually the ball passes the nth step. So I can actually write these actually words in terms of actually a mathematics expression, something like this, that we should understand that R delta R 0 plus delta R1 plus delta R2 plus until plus delta Rn minus 1 should be actually greater than L. Why? Because this actually this M1, for example, M0 B0 is 1, L, M1 B1 is L, M2 B2 is L, and these deltas actually we have a cumulative actual lengths, which they are actually we are adding them to each other, and after the n minus 1th collision, the ball actually passes the nth step and it doesn't collide to it. So I can say that delta R0 plus delta R1 until delta Rn minus 1 is going to be greater than L. Okay. But for doing this sum, actually for calculating this sum, let me to actually calculate directly and find the delta Rn as a function of n, not as a function of Tn and delta Tn. Let me to find it as a function of n. So let me to erase it for now. Let me to copy this for now. Before that, we should actually, we want to calculate delta Rn as function of n directly. So let me to write it again. Delta Rn is going to be cosine of theta, which is not anything. We have theta, we shot the ball with the initial angle theta with respect to the origin. Also V0. And what was delta Tn? Here we understood that delta Tn is something like this. Let me to copy this and paste it here. Let me just erase the positive sign here. It is not, it's multiplying. So this plus delta V0 Tn. What was Tn? It was just Tn. Let me again to copy this and paste it here. It was just our Tn. So I can, if I factor, actually you can see here that I can factor V0, delta V0 sine theta over G. So I can say that delta Rn is going to be V0, delta V0 sine of theta, cosine of theta over G. I factored V0 and delta V0 sine theta. Here we can see just E1 plus E to power 2n plus, and here I can see, if I factor this term, I can see just 1. Let me to write it like this, E plus 1 over E. Then again I can factor the 1 plus n, so it's going to be V0 delta V0 sine theta cosine of theta over G times 1 plus E, and E to power 2n plus 1 over E. We found this as Rn. So now we can write this equation, and that delta R0 plus delta R1 plus delta R plus delta Rn minus 1 is going to be greater than L. So I can say that this parameter is constant and I want to call it, for example, gamma. So it is gamma e to power 2n plus 1 over e. So I can factor these gammas and say that it is just e to power, if I say it is, if I put n as 0, it is 1 plus 1 over e, plus if e to power 2 plus 1 over e plus e to power actually 4 plus 1 over e plus until e to power actually 2 n minus 1 plus 1 over e, and I can write it as just gamma times n minus 1 ones plus, sorry, n minus 1 over e, n minus 1 over e plus actually 1 plus e2 plus e4 until e to power 2n minus 2. I can say that this expression is a. I want to calculate a. A is just 1 plus e2 plus e4 plus until plus e to power 2n minus 2. I can multiply it with e2. e2a is going to be e2 plus e4 plus until plus e to n. If I subtract these two equations from each other, then a 1 minus e2, this term is going to eliminate this term is going to eliminate, and this term is going to eliminate this. It's going to be 1 minus e to power 2n, so a is going to be 1 minus e to power 2n over 1 minus e2. So gamma n minus 1 actually over e. Let me check something. E to power this, it is yes, it is true, I think. True. So it's okay. N minus 1 over e plus a, which a was just 1 minus e to power 2n divided by 1 minus e2. And this should be actually greater than L. It should be greater than L. So we found the condition, sorry about this, we found the condition of the find n. Actually n is the minimum, actually if you find the minimum n that actually satisfies this inequality, you are going to find n. But let me to actually calculate this n for these parameters that the question tells us. If we have e, epsilon, and also L divided by AB, L divided by AB. So here you can see that if what was gamma, we should calculate gamma. Gamma was actually calculating gamma. Gamma was actually V0, delta V0. I can say that delta V0, we know that this is epsilon, so I can say that delta V0 is going to be epsilon V0. So I will do something like this: epsilon V0 square sine of theta cosine of theta over G times 1 plus E. 1 plus E. So what is V0 and what is this term V0 sine theta, V0 square sine theta? From here you can see that we obtained V0 sine theta and V0 cosine of theta from these expressions. If I actually copy this expression and paste it here, we have actually this term. We have this. If I actually oh, it is so messy. 1 minus e2, and it was something like, I forgot it, v0 cosine of theta. I need to copy it again. what was v0 cosine of theta? It was this. Okay, copy it and paste it here. Oh, and it is so messy. I should write it. If I want to write it, I think I can write it. v0 cosine of theta was just, I think, it has gh cotangent of alpha divided by 1 plus e, I think, radical, the inverse of this term over 2gh. I think it was something like this. Let me see. It was yes, it was this. If I actually multiply them with each other, I can obtain v0 square sine theta cosine of theta as this is going to eliminate actually this, and we just have e g h cotangent of alpha over 1 plus e, which I can actually divide both sides with g, and now I actually have this expression we square here, and I can actually, let me to call this actually the square equation. I want to call it the square equation. By square, if we substitute it in a square equation, we can obtain that epsilon 1 plus e is going to be multiplying by actually e h cotangent of alpha divided by 1 plus e, which I can do something like this, which it is going to be, it is gamma. Is gamma, which gamma is going to be something like epsilon e h cotangent of alpha, but we don't have actually the problem didn't tell us what is h cotangent of alpha. No problem if I substitute this gamma in this inequality from the inequality. Let me to call this again, this inequality, as double star inequality. So if I actually substitute it in the double star inequality, I can obtain that epsilon e h cotangent of alpha times, actually, what was that? What was the next? N minus 1 e is n minus 1 over e, 1 plus 1 minus e to power 2n, 1 minus e2, I think. Yes, it is true. It should be greater than L. But if you actually pay attention, we have L, E, which it is equal to something like this, which AB is just the length of the base of, I told you that I want to call it base. It is just the base. So it means that AB is equal to AB is just equal to H cotangent of alpha. So L is going to be just something like this, which is equal to L. And now I can, because H and cotangent of alpha is just, they are positive, I can remove them from both sides, and now I have epsilon times E, epsilon times E, n minus 1 over E plus 1 minus e to power 2n over this term is going to be greater than 0.8. And we know that epsilon is just, we can divide it by epsilon, which it is just 0.06, and e is just it was 0.75. Let me to say that we divided by that, and it is something like this. So I can say that 4 over 3 n minus 1 plus 1 minus 3 over 4 to power 2n, or 1 minus 3 over 4 square. It should be greater than this. There. Note that we should find the minimum n that satisfies this. We should find minimum n that satisfies this inequality. We should find the minimum n, and I think if we actually find, if we do some, if we actually calculate this term, and actually we can do we can do actually something like this. We can actually graph this the left side, and we substitute n as x. For example, we consider that it is a function of x, it is a f of x, which n is x, and we can graph it and also graph left to the right side, and then actually, for example, this is something like this, and then understand this is f of x, and this is also the right side of inequality, and then understand that what is this n. For example, it is going to be, for example, 4 over, for example, 4.6. So our answer is going to be 5. Or for example, if it is 5 or 5.6, our answer is going to be 6. I think our answer is going to be actually, let me to check, and I will write here the answer. Okay guys, I checked the equations, the inequality. I do what I said. I actually replaced n with x, and actually here, as you can see in this part, we have f of x, which it is 4 over 3 x minus 1 plus 1 minus 3 over 4 to power 2x, which x is n. And here we have the green graph, as you can see here, and also the right side is equal to 160 over 9, which it is the black, it is the gray graph, and you can see here that n equals 12, below it means that before that n reaches to n equals 12, our this side, the left side, is less than the right side. But just after the 12, it means, for example, for the 13, which it is something like here, which it is 13, we actually have our in fact our left side is going to be greater than the right side, and also we should find the minimum n that satisfies this inequality. So I think the right answer of part B is actually 13. It means that with these assumptions, our ball is not going to hit to the 13, it's not going to actually hit the step number 13. Okay, it was a very good question. It was a very long question. You should actually be aware about the motion equations, and you should be very flexible with them. And also you learn something new about approximations, that you can actually neglect some terms that are very small and you don't need to actually use them. And yes, you should actually I think that it was a very good question, and if you are a physics lover, or if you are working with Physics Olympiads, I think it's very going to be useful for you. We wrote a lot, and I hope if you enjoyed this video, if you really enjoyed this video, please like this video, and please comment below and let me to know what you think about this question. And if I did something wrong, because it was so hard, I think it was a little hard,
maybe I make some mistakes in it, I will be happy if you actually comment below that where did I make mistakes, so that I can correct them for you guys who are watching this video. And if you think that our actually channel, our work, our purpose is going to be useful for you, I will appreciate you if you actually subscribe our channel and tell us what do you want, and what the fields are you for example uh, fall in love with, so that we can record some videos about that fields of, for example, physics or mathematics or something like that. That was the Iran's Physics Olympiad. It was a hard question, and I hope you enjoyed it. Thanks for watching. Thank you very much.